Now I know that there's this bushing here, or collar, or whatever you want to call it, actually is what's retaining that that little pin that's broken off that locks into the slot. Locks into the slot on your standard R8 collar right here. So I'm going to, that's a lot easier to take off. You have to slide that out of the way to take that pin out. That's a lot easier to take off, obviously. It looks like it's impossible to change that pin without having this move out further. I thought for some reason it was exposed once you took that nut off, but I don't see it. So next step is on the old style or this style, whichever came first, you have to remove that bearing retaining nut, which is a pain in the butt, unless you have the special tool, which I tried everywhere to find one. Even Wells Index said they just make one in the shop special to do it. So on this one though, you got a nice little snap ring down in there. We just get that snap ring out. And what better thing to do that with than my handy dandy high quality Harbor Freight snap ring pliers. As cheap tools go, this, I gotta admit, wasn't bad. It's served me well on more than one occasion. Oh, I already got it set up. I don't know if I get the right size tips on it. Get some of that grease out of the way. Yeah, those look kind of small. It's ratcheting feature on these is nice, but it also is kind of a pain when you're first aligning it. So ideally, if there was a way to lock this in the off position until you get it in there, that would be nice. Ergonomically, that's the only thing I find wrong with these. Yeah, those are, I gotta change these tips, they're too big. Heck, I could have sworn this had smaller ones. Oh my goodness, I can't even use this. After all that hype about how great this thing is, I can't even use it. I gotta use my super cheap ones that I hate using, but I actually have these right here. These came in a lot of something I bought, and they've got really fine points on them. And it worked. Gotta love that. Alright, now believe it or not, one good tap or two, and this whole spindle assembly with the bearings on it is going to come out. There's a non-marring hammer or dead blow mallet. And I could also have pressed this out. So once you get it out to this point, now you can grab this, oh maybe not, it's on there kind of tight. Yeah, I thought on the other one this slid off pretty easily. Could be the head of the broken pin is stuck in there too. Oh, the other trick, I forgot. The other trick is to just put a block of wood on the table, invert the thing, and use the weight of the whole quill to assist in the removal. And for those of you who think this looks horrible, I'm stealing this idea from a video of a professional shop that rebuilds these. Wow. That's a different design. That's a different design. Oh my. I certainly hope that doesn't mean that I can't use this. Spindle. 9/17. Uh-oh. Wife's out of town, so I gotta make Sunday morning breakfast. Alright guys, I cleaned up the components in the parts washer, and now I've got the two assemblies side by side because I want to see exactly what I'm dealing with, if these things are going to be compatible. Now the quill already slid in there, so I know it's going to fit that way. And it looks like they're exactly the same size, so it doesn't look like the quill changed. And the shaft, if I take my original shaft, you can see the difference in the design here. On the original shaft, we've got, let me get this in there right, so we can pretend it's back together. Alright, so on the original shaft, you can see there's a bearing there's a spacer, and there's a bearing. And what they do at the factory apparently during assembly is they precision grind the sides of the bearings, and then this is a very precise length, so that when you fully tighten up this locking nut, which is identical on both of them, when you fully tighten up this locking nut, this sandwich gets compressed, and it's the proper amount of preload on the bearings. At least that's my understanding of it. So on this one here, good news is the two shafts are the same length and the splines are identical on both. So the design's just a little bit different. This one has a bearing at about this position. This one has the bearing a little higher up here. So this one was further down in and harder to get to. So the upper bearing is closer to the stack down below on this one. But on this one, at the spindle end, the two bearings are stacked right on top of each other, and they must be precision grinding the sides of the bearing so that when that gets tightened up, you've got the proper preload. Again, that's just an assumption. But anyways, what we're looking at now is there's no reason why these shouldn't be able to interchange from what I can see. So I think I'm going to be able to continue on with my plan, which is to use this in my head instead of having to swap out the head from that other Bridgeport, that other Wells Index. The reason why I said Bridgeport was because I wanted to make another point. I actually think that the whole design of the two bearings stacked down here and the one bearing up here, the way this layout is, I think this is actually how the Bridgeports are, or at least on some of the Bridgeports that I've seen videos of rebuilds on. I think that's how the Bridgeport did it. So at some point I think I'll give Wells Index a ring, and I'll run the serial number on the other machine, and I'll see which one is newer. Because I'm curious whether or not they had this design originally and then went to this design, or did they have this design and then went to this design? You know, was this an improvement over this? If it was, it's still not enough for me to abandon my plan, because I can't use this spindle with this bearing setup, obviously, because of the way it's made. So this is a completely different deal. Alright, so now that I have satisfied myself that that's going to work, I can put all of this stuff off to the side. So what I want to do is, I don't want to make the mistake I made in the last disassembly, which was when I took the bearings off, I didn't make note of which bearings were where. And now that I understand how the preload on these bearings works, I understand that it's going to be critical that, that these bearings go on in the same order as I take them off. Not only that, but it's going to be critical that they face the proper direction. Two reasons. For one reason, if these bearings are like the ones on the other one, these are angular contact bearings. Second of all, I want the same ground sides facing the same way, so that I can make sure I keep that preload that they built into there correct. So now, I still can't get that sleeve off. I actually don't need to get the sleeve off right now. This sleeve hides the end of the pin that goes on here, if this even has a pin. You know, it just occurred to me, maybe this doesn't even have a pin. Maybe this relies strictly on... Nope, I see it. Here's the pin. In fact, I can feel what little bit of is left in it. So that's sheared off at some point. I wonder if with that pin sheared off, if that could have caused a situation where the collet was able to loosen up, which allowed that end mill to slide down, and could be responsible for the damage on that table. Because the damage on the table starts shallow and digs deep, almost as if the end mill was coming out as it was going across the table. Either that or somebody engaged the feed, the automatic feed for the quill while it was running. Alright, no need to dwell on that any longer. So the next order of business is going to be to remove this locking nut. I think what I ended up having to do on the last one was I had to grab the splines here with a pipe wrench, but I wrapped them with a rag. So right now I can't think of another way to grab this. Yeah, that ain't gonna budge. No, I'm not damaging that. The sock is protecting it, but the problem is the sock's also letting it slip. Oh my god, I can't believe how tight that is. No, I thought it actually broke free, but it just slipped out of the groove. I wonder if they put any thread locking compound on that. I've got a hole over here on my workbench that has come in quite handy on more than one occasion. What I did was I stuck the wrench down in there, so now it doesn't move around on me, and that allows me to put a helper on here and really put some force on it. And I actually just broke it free right before I decided to hit the camera and show you how I ended up doing it. I wonder if this is a self-locking type of deal or something. This bearing retaining nut. Because even now that I've broken it free, it turns tough. Turns tough. I'm going to have to leave soon. Promised the boys I'd take them out to brunch. Sunday brunch. Putting on airs, huh, Steve? No. It's just a really late breakfast, early lunch is what it is. At Carl's Diner, an Oxford, Massachusetts institution. I highly recommend that if you find yourself in Oxford, Massachusetts, why, I'm not sure. Hey, maybe you were kidnapped and managed to escape in Oxford. Well, before you go to the police station, you might want to get something to eat at Carl's. It's the old New England diner style type of place. And they get a little seating area in the rear too if you've got a larger party. But they really put on some good grub. Okay, that's done. Alright, so now I want to remove these bearings. And these bearings have to be pressed off in this direction, which means I've got to get this nut all the way off. So I've got another clip I've got to remove here before that's going to happen. This nut's got a beveled side that goes up against the bearing, so that's pretty straightforward how that goes on. Now the bearings can be pushed off this way, but they've got to be pressed off this way, and the trick is that I don't want to push on this outer race of the bearing to do this. So I've got to be able to see that inner race. So I think what I want to do is see if I can't now get this ring off. Well, that's certainly interesting. There's no visible shoulder there of the inner race exposed. Not enough to let me do what I want to do, which is push these bearings off this way without putting any force on the outside race. That's kind of weird. Does that mean that these aren't a tight press fit? Kind of doubt that. Well, there's the remnants of the little pin. So you can worry about taking that out later. Just grab a puller. I swear this just slipped on loosely on the other one. Oh, you know what? This swarf stuck in there. No wonder why it didn't want to come off. This is actually out of round. This is actually no longer a circle, and there's a big indentation where the head of this right here pushed out on this. So what probably happened was when this snapped, there was still enough of it sticking out, and the collet spun in there and caused that to push out with enough force to actually bend this. That's why this doesn't go on here the way it should. Should just slide on. So I could probably take the one off of my spindle and stick it on there. I've got it somewhere. Maybe that's also why this is kind of really stuck in there. Jammed up good. That's it right there. That little sucker right there is not supposed to be as short as it is. Alright, so that settles that. Now the question is, how are you supposed to get these bearings off of here? These bearings have to go this direction. So you've got to push them off in this direction. But I was always taught you're not supposed to push on the outer race of a bearing. Just trying to get a feel for how tight these things are. They're pretty darn tight. Boy, you take the load off, preload off of those things, they get real loud. Well, I can tap just a little bit here on this inner race because this little slot that's in here is giving me just a little bit of clearance visible there. I'm not going to tap too hard though. Yeah, that's not a tight press fit because that's moving fairly easily. Okay, so this end, what I've got facing up right now is facing towards the opening for the collet. So for markings, what I see on here is I see an M on the inner race, and that side's a little nasty. Alright, so I gotta make sure I keep these bearings straight. So right now the only marking I see on this top one is on the inside I see an M. This is a Fafner bearing. Looks like it's an 8016, which I think is what we had in the other one. Alright, so this top bearing right here is the one that is closest to the R8 end. Inner race M towards R8 end. Thrust faces away from R8 end towards upper bearing. So the writing on these two bearings face each other. This bearing here has discoloration on this little ball retaining thing here because of when I used the torch earlier to free that thing. So this is going to be the one that goes back on first. So this is going to be the first one I'm going to clean and pack. Builds up quite a bit of pressure, that off-gassing, when you agitate it. That's going to blow again. The grease that's stuck in there is the consistency of wax. Alright, so I hit the bearings with 3M solvent first, agitated it, get all the heavy stuff out. One of the bearings, there was a lot of hardened wax, like grease that I had to pick out. Then I ran them through the parts washer, and then I rinsed them with hot water. And now I'm going to put them in my toaster oven here, my junk toaster oven, just to drive all that moisture out of the bearing. So I'm only going to make these, warm these up enough to dry them out, and not so hot that they could be damaged. Well guys, it's been a couple of days since I've been down here cleaning these bearings, and after I rinsed them, I put them in my little toaster oven here, and I cooked them just hot enough to drive all the moisture out so I wouldn't have to worry about any flash rust. And so I was excited about the prospect of maybe coming down here and repacking them with grease tonight, putting this back together. I purposely put them in here so that the one on the left side is the first one that has to go on to the shaft. So that's all fine and dandy. Problem is, I forgot about the third bearing up at the top here. I never took that one out and cleaned it, so I've got to do that before I can do anything else. Well, it took some light tapping to get that bearing to come out. It's a very light press fit. Actually, it's more like a slip fit than anything. Which is good because you can't get, because of the way this is made in here, in this bore, you can't drive anything in from this side and actually only put pressure on the outer race. It's a blind, well, it's not really a blind hole, but in other words, I've got this right now. Got this facing up, and so this bearing just came out of here. I had to drive it out from this way because there's a ridge in there that outer race sits on, so that when you look down from this side inside here, that diameter is actually quite a bit smaller. You can't even see that outer race. So that creates a whole interesting problem of getting this out. This bearing is different than the other two in the fact that it has a metal shield. It is shielded. So I just want to make a note of which way this goes in. So I see writing with the bearing number on this side, on this one, and so that's facing up right now, but when I flip this over, this side with the numbers on it is going to face the end where the collet goes in, the spindle nose. This side doesn't have a metal shield on it. So the metal shielded side faces the spindle nose, and the this side over here, which has a little ghost mark where the snap ring actually was, that faces up. That bearing feels a little crunchy. That's got some garbage in it, you can tell. Try and clean this up and see if it improves things. Get as much of the heavy dirt off as I can. Now I know why this one was shielded. Actually, this is shielded on the top too. It's just discolored. Well, that's just wonderful. So that's a fully shielded bearing, so I can't get this apart to clean it and do anything else to it. Son of a gun. Well, since this is a lone wolf bearing up here, it's not going to be the same kind of animal as the sophisticated angular contact pair that are facing back to back at the bottom. Since this is a lone wolf, this might not even be an angular contact bearing. This might be just a, you know, plain old. Matter of fact, this looks like it's 6007. Yeah, this is not a special bearing. So I'm going to replace this with a new one. It's going to cause a little delay that I'm not thrilled about, but it's going to make more sense for me to do that than, I mean, this sounds horrible.